Hello and welcome to the next video. The question is, the step response of an LTI system is given by 1 minus e raised to minus t e raised to minus t of t. For an input x of t, the output is observed to be 2 minus 3 e raised to minus t plus e raised to minus 3t of t. For this observed measurement, determine the input to the system using Laplace transform. Okay, so for an LTI system, the step response is given, right? Step response means output of that system for an input step signal. Okay, output of the system for a step signal as input, that is given by 1 minus e raised to minus t minus t e raised to minus t of t. Okay, now for any input x of t, an arbitrary or particular input x of t, the output observed is also given, that is 2 minus 3 e raised to minus t plus e raised to minus 3t. Okay, so the question is to find out that input x of t. Okay, so this is very simple. The first statement gives us the step response of an LTI system, and that is, okay, when x of t is equal to u of t, the output y of t equal to, that is called a step response. That step response is given in the first sentence, 1 minus e raised to minus t e raised to minus t the whole into u of t. Okay, so what can you calculate from these two, just this two information? It is nothing but h of s, right? Because you have x of t, so you know x of s. You have y of t, you can calculate y of s. So with x of s and y of s in hand, we can easily calculate h of s. H of s is equal to y of s by x of s. Okay, so if you know h of s, we have a new input x1 of s, or in the question is given x of t. I can write it as x1 of s. It's Laplace transform. Then to find out then if x1 of s is applied to the same system, the output given as y of t or y1 of t, which is given in the second expression, this one. Okay, fine. So the question is to find out x1 of t. So we know h of s is constant for any input, right? So for this input output combination also, this h of s we have calculated is valid, right? Therefore x1 of s will be equal to y1 of s by h of s. Okay, so this is how you calculate the new input. H of s is known, y1 of s is given in the second sentence. So this is very simple to find out x1 of s, and once you get x1 of s, the inverse Laplace transform will give you x of t. Okay, x of t. So let us so this is the strategy to do this problem. So let's start solving this. So first we can write x of s. X of s is equal to 1 by s. Laplace transform of u of t is 1 by s. So y of s will be equal to Laplace transform of the signal, that is 1 by s, right? Laplace transform of 1 will be 1 by s, minus Laplace transform of e raised to minus t is 1 by s plus 1, minus Laplace transform of t e raised to minus t is 1 by s plus 1 the whole square. Okay, so that is y of s. Now with x of s and y of s, it is very simple to find out h of s. H of s is equal to ratio of y of s and x of s. Okay, y of s by x of s will give you 1 by s minus 1 by s plus 1 minus 1 by s plus 1 the whole squared, whole divided by x of s is 1 by s. Okay, 1 by s. So this will need a little bit simplification. Taking the LCM in the numerator, LCM will be s into s plus 1 square. So this will be s plus 1 the whole square minus s into s plus 1 minus s whole divided by s into s plus 1 the whole square, divide by denominator is 1 by s. You can cancel this s, and finally h of s will be equal to, this will give you s plus 1 square by s plus 1 square minus s into s plus 1 by s plus 1 square minus s by s plus 1 square. Therefore, finally I can write h of s is equal to 1 minus s by s plus 1 minus s by s plus 1 the whole square. Okay, this h of s will be constant for whatever input you give. Okay, now we will consider the second case where another input is given. Okay, another input x of t is given, and the output observed in the question was if I'm right, it was 2 minus 3 e raised to minus t plus e raised to minus 3t into u of t. Okay, that's the new output, y1 of t. Okay, so what is y1 of s? Y1 of s is very simple to observe. Is 2 by s minus 3 by s plus 1 plus 1 by s plus 3. Okay, now h of s is constant. Okay, therefore you know h of s is equal to y1 of s by x of s, which is a new input. That implies x of s is equal to y1 of s by h of s. That is equal to y1 of s is 2 by s minus 3 by s plus 1 plus 1 by s plus 3 whole divided by, what is h of s? H of s is 1 minus s by s plus 1 minus s by s plus 1 the whole square. Okay, again we cannot stop here because what we have obtained is just x of s, but we have to find out x of t. So x of s is equal to, I can find the LCM again in the numerator, right? This is the numerator. LCM will give you 2 into s plus 1 into s plus 3 minus 3s into s plus 3 plus s into s plus 1 whole divided by s into s plus 1 into s plus 3 divided by, I have to take the LCM of the denominator, which is s plus 1 the whole square minus s into s plus 1 minus s whole divided by s plus 1 the square. You can cancel 1 s plus 1 here. Again we can simplify it. So the numerator becomes 2 into s square plus 4s plus 3. So 2s square plus 8s plus 6. Okay, minus 3s square minus 9s plus s square plus s divided by, I can write it as s into s plus 3 into s plus 1 the whole square is s square plus 2s plus 1 minus s square minus s minus s. Okay, into s plus 1, right? This s plus 1 goes to numerator, right? And this s into s plus 3 goes to denominator. That's what I have done in single step. Now this becomes minus 3s square plus s square means it is minus 2s square, and that can cancel, right? Then s minus 9s is minus 8s, that will cancel with 8s, and what it is left here is 6. Okay, so this is in the numerator it is 6 into s plus 1 divided by, in the denominator we can see s square minus s square gets cancelled, 2s minus 2s cancelled, so 1 is left. Okay, so 1 into s plus 3. So this is x of s. X of s equal to 6 into s plus 1 by s into s plus 3, right? Now it's only a matter of making into partial fractions. So this is a by s plus b by s plus 3. You can adopt any method to find out a and b. I think I will go on with the simplest easiest method. Here this is equal to what is a? You just observe what value of s makes this denominator to 0, that is s equal to 0, right? Apply s equal to 0 to all terms here, neglecting s here. The same s is here, you have to neglect it and apply s equal to 0 to all other terms. So that will give you 6 by 3, that is 2. So 2 by s, okay, plus what is b? B is, observe what value of s makes this denominator 0, it is s equal to minus 3. So put s equal to minus 3 in all terms except for s plus 3. You have to neglect s plus 3. The same term here occurs, you have to neglect that. And put s equal to minus 3 in all other terms. So that becomes 6 into, I can write it here, 6 into 1 minus 3 is minus 2 divided by minus 3, right? So this becomes 4, right? So 4 divided by s plus 3. So this is how you simply find out. It's an easy step to find out a and b. So x of s, we have got it as 2 by s plus 4 by s plus 3, and fortunately both the terms in x of s are standard or in the form of standard Laplace transforms. So it's very simple to find out x of t. What is the inverse transform of 2 by s? It is 2 into u of t. Plus what is the inverse transform of 4 by s plus 3? It is 4 e raised to minus 3t u of t. And that is the final answer. We have obtained x of t. Alright, the next question is, state the sampling theorem for Laplace signals. That's only 2 marks question, and we have dealt with this question many times before in the previous videos. So again, sampling theorem deals with the sampling of a signal and reconstruction. You have to be very careful about reconstruction. That's the main point. So a signal, a low pass signal band limited to FM, maximum frequency of FM, can be sampled and reconstructed back from the samples only if the sampling frequency Fs is greater than or at least equal to 2 times FM. Okay, so that is sampling theorem. Okay, the next question is, determine the Nyquist rate of sampling for the signals. The first question, x of t equal to 2 sine 250 pi t plus 3 cos square 500 t. X of t is 2 sine 250 pi t plus 3 cos square 500 t. Okay, determining the Nyquist rate of sampling is very simple. All you have to do is identify the maximum frequency component in the given signal. Identify the maximum frequency component in the given signal, which is FM. Now, if you get FM, the Nyquist rate is given by Fs is equal to 2FM. Okay, you find 2FM, that is your Nyquist rate of sampling. So, let's come back to the given signal x of t, what is the maximum frequency component? Actually, there are 2 frequency components, one for sine. You know, sinusoidal signal is a singleton signal. It has got only a single frequency component that you have to be thorough with. Okay, so in this x of t, there are 2 sinusoidal signals, and each contribute to 1 frequency. So there are 2 frequencies. But in this term, it is very simple to identify the frequency component, which is 250 pi. Omega will be 250 pi, and the frequency will be divided by 2 pi. Okay, but from this term, it is difficult to find out. Not difficult, but it is not that direct to find out the frequency. So what we have to do is, we can simplify this signal so that this cos square term is eliminated, and we know cos square theta will be equal to, cos square theta is equal to 1 plus cos 2 theta by 2 whole divided by 2. Okay, so I can write it as 3 divided by 2 whole divided by 2 is taken into 1 plus cos 2 into 500, that is 1000 into t. Okay, That means it is 2 sine 250 pi t plus 3 by 2 plus 3 by 2 cos 1000 t. In the meanwhile, we have introduced a 3 by 2 here. That does not make any difference because it adds only a zero component, zero frequency component. It's a DC term, okay? So it adds only a zero DC component or zero frequency component to the signal. So now we have two terms, okay? Two sinusoidal terms, sine 250 pi t and cos 3 by 2 cos 1000 t, okay? So what is the frequency component of this term? Let me denote as f1. So what is f1? 250 pi is omega or omega 1, okay? And we know omega and f are related as omega is equal to 2 pi f. So what is f? F is omega by 2 pi. So you identify omega here divided by 2 pi. So f1 equal to 250 pi by 2 pi, which will give you 125 hertz. So the frequency that results from, that is associated with this term, this sinusoid, is 125 hertz. Okay. Similarly, we have one more sinusoidal term, that is cos 1000 t, and here omega is or omega 2 is 1000. So what is f2? F2 is equal to omega 2 by 2 pi, which is 1000 by 2 pi. That will be equal to 500 by pi. Okay, so if you calculate 500 divided by pi, it will give you 160 hertz. Okay, you substitute 3.144 pi and you will get this answer. Okay, so you have two frequency components in the signal, 125 hertz and 160 hertz. Which one is greater? It is 160 hertz, right? So I can write the maximum frequency component or the greatest frequency component in the given signal is 160 hertz. Therefore, now it's very simple. Therefore, Nyquist rate for sampling is given by Fs is equal to 2Fm, which is equal to 2 into 160 hertz, and that is 320 hertz. So this is the Nyquist rate for the first signal. Okay, moving on to question B. Now the signal x of t is 10 sing 500 t. Okay, now this question is a bit catchy. You cannot identify the frequency component as directly as we have done in the question A, but we know sing signal. What is sing t? Sing signals or sing t is given by sine pi t whole divided by pi t, or 1 by pi t into sine pi t. That is sing t. Okay, now what is sing 500 t? Therefore, sing 500 t. What is the difference between this equation and this equation? Here the variable was just t, and here I'm changing the variable to 500 t. So in the RHS, in the would-be RHS, what I have to do is wherever I find t, I have to replace with 500 t. So sing 500 t will be sine pi into, instead of t, it is 500 t divided by pi into 500 t. Okay, so now I can rewrite this equation as x of t equal to 10 into sing 500 t is sine 500 pi t divided by I'm writing it as 500 into pi t. Pi into 500 t is 500 into pi t. Okay, so that is equal to 1 by 50 into sine 500 pi t divided by pi t. Okay, now you have to remember one important relation. You can always remember this. If sine 8t by pi t is your time domain signal, then its Fourier transform will be a rectangular pulse. It's a rectangular pulse, okay, n rectangular pulse whose width or which starts from minus a to plus a in omega domain. Okay, and with magnitude 1. I can repeat, if sine 80 by pi t, this is a sync signal, this is very much a sync signal. If sine 80 by pi t format is given to you as in time domain, then its frequency response will be, or frequency domain will be, a rectangular pulse, and the speciality of that rectangular pulse is it is non-zero only from minus a to plus a. You can see a here, it is a coefficient of t, so it is non-zero from minus a to plus a, and most importantly, remember, this is in omega domain, not in f domain. Okay, this is in radian per second, not in hertz. What should be done to convert it into frequency in hertz? You divide by 2 pi, right? Divide by 2 pi on every value, you will get frequency in hertz. So this is an important result you have to remember. So so what you know, what you have in hand is 1 by 50 into sine 500 pi t by pi t. So it is of the form sine 80 by pi t, where a is 500 pi. Is that right? Of course it is. So what is the Fourier transform? Therefore, Fourier transform of x of t will look like this. Okay, in omega it is, if it was sine 80, it starts from minus a to plus a. So it is, if it is 500 pi, it starts from minus 500 pi and it should end at plus 500 pi with amplitude 1, but we have a 1 by 50 scaling here, so 1 by 50. Okay, so this is the Fourier spectrum or Fourier transform of 10 sinc 500 t. Now if you convert it into frequency domain, hertz, this is in radian per second. If I want to convert it into hertz, you can simply do it by dividing every x value by 2 pi. Okay, so amplitude will not be affected. So in frequency or in hertz, this is minus 500 by pi divided by 2 pi. I can write as divided by 2 pi. So this is minus 250, and this is 500 pi by 2 pi will give you 250 plus 250. This is in hertz. Okay, so in this given signal x of t, we have found out that the maximum frequency component is 250 hertz. Okay, so we can boldly write fm is equal to 250 hertz. Therefore, what is the Nyquist criterion? Nyquist criterion for sampling, fs is equal to 2fm, which would give you 2 into 250 is 500 hertz. So that is the Nyquist sampling frequency. Getting on to the next question. A signal x of t is sampled with a sampling frequency 800 hertz. The question is simple. Write the resultant discrete time signal. Okay, this question is very simple. Sampling always gives you a discrete time signal. In fact, sampling is the method used to convert a continuous time signal into discrete time signal. You know that. Okay, so if x of t is the continuous time signal, and on sampling you will get a discrete time signal which can be expressed actually by x of n ts. Okay, which is x of n ts, where n is an integer and ts is equal to the sampling period in time domain. Okay, so x of n ts is the representation of the discrete time signal obtained by sampling. So in the given question, you are given an x of t and it is specified that sampling frequency is 800 hertz. So sampling frequency given by fs is 800 hertz. Okay, so what is the sampling period? Sampling period denoted by ts. What is the relation between fs and ts? It is reciprocal relation. So ts is 1 by fs, that is 1 by 800 seconds. Okay, now how will you find out the resultant discrete time signal? You can represent it as x of n ts. X of t is converted as x of n ts. That is equal to x of t is actually 2 cos 400 pi t plus 6 cos 600 pi t. When you write x of n ts from x of t, right, x of t is written as x of n ts. So what change might be there? Wherever you find t in the signal, you replace it by nts. You know, ts value is 1 by 800, you know. Okay, so wherever you find t, change into nts. So 2 into cos 400 pi into t should be changed into nts, right? Nts. So n into, what is ts? 1 by 800. Okay, this is in the argument of cos, plus 6 cos into 600 pi into, again there is a t, you have to change into nts. Nts is 1 by 800. Okay, so there is a little simple simplifications. So what you get is x of nts is equal to, or x of n by 800 is equal to 2 cos pi n by 2 plus 6 cos 3 pi n by 4. So this is the final answer. Let's master the next question. Find the Fourier transform of the following signals x1 of t and x2 of t. Any relevant properties may be applied. The question is very straight. You have to find out the Fourier transform of x1 of t and x2 of t. Actually, these two are separate questions. You can write A and B. Okay. So, never get scared on finding these questions. Never get scared on seeing to find out the Fourier transform of these questions, because finding the Fourier transform of these two questions, these two signals, are as simple as snapping your fingers. So be confident. I will help you how to solve it. First of all, let us take question number A. I'm taking this signal separately. Okay, so x1 of t is a triangular signal, right? On a simple inspection, you cannot find out the Fourier transform as such. So what I'm going to do is, I'm going to differentiate the signal. I will draw how the differentiation of x1 of t, that is d by dt of x1 of t, looks like. Okay, listen here carefully how we can draw the differential of the signal. So we are applying or finding the differential or derivative of the signal. I can represent as d by dt of x1 of t. Okay, so what is actually a differential? It is nothing but finding the slope of a graph. The signal is a graph actually, a function actually. It is finding the slope of that graph. So let us take this interval 0 to t. What is the slope of the signal within 0 and t? It is nothing but delta y by delta t. Okay, delta y is 5 and delta t is t. So 5 by t is the slope. So within 0 and t, I can write t here and 2t here. Okay, so from 0 and t, within 0 and t, the slope is 5 by t. So I can represent it like this. Slope is constant 5 by t, right? 0 to t is 5 by t. So the slope d by dt or slope is 5 by t. Okay, now what is the slope between t and 2t? This is the graph. And what is the slope between t and 2t? The slope starts from 5 volt and ends at 0 volt. Okay, so what is delta y? Delta y is 0 minus 5 is minus 5, and the delta t is 2t minus t is t. Okay, so delta y is minus 5 because it is a downward slope signal, so slope will be negative, of course. So minus 5 divided by t. Slope is minus 5 divided by t. So I can represent it as slope is constant, which is minus 5 divided by t. So I can represent it as minus 5 by t. Okay, so now can you find out the Fourier transform of this d by dt of x1 of t, which is a square signal? Again, it is a bit difficult, right? I have told you it is finding the Fourier transform is as simple as snapping your finger. So again, this one is also a bit difficult. So what would you know? What would you do? I recommend you again you find out the differential. Again you find out the differential of the signal. Okay, let's see what happens. I will draw it for you. Okay, let us see how this will come. So what I'm taking is first x1 of t, then d by dt of x1 of t. Again I'm finding the derivative, so it should be d square by dt square, d square by dt square of x1 of t. Okay, so again d square by dt square x1 of t will be the slope of this signal. Okay, the slope of this, I have to find out of, I have to represent the slope of this signal here. And how would it come? Let's see. What is the slope of the signal at t equal to 0? At t equal to 0, you can see an abrupt rise. Okay, an abrupt rise. What is the slope of that abrupt rise? Is nothing but an impulse function. Okay, it is infinity. Actually the slope is infinity, and in signals we represent infinity by as an impulse. So there is an impulse here. Okay, what is the strength of that impulse? You know, the abrupt changes from 0 to 5 by t, that means 5 by t units. So 5 by t into del of t is this signal. Okay, so that is the slope. Now what is the slope between 0 and t? Between 0 and t, the function is a signal is a straight line, the slope is 0. So I can represent between 0 and t, the slope is 0. So d square by dt square x1 of t will be 0 there. And now be very attentive. What is the slope at t equal to t for this signal d by dt x1 of t? There is again an abrupt change, but this time the abrupt changes from 5 by t to minus 5 by t. So what is the total change? It is 10 by t, right? 5 by t to 0 and 0 to minus 5 by t, you will get it as 10 by t. So there is a 10 by t strength impulse signal at t, right? And the orientation of that impulse will be negative because you know the voltage changes from positive to negative in this direction, positive to negative in this direction. So the impulse will be negative, and the strength of the impulse is minus 10 by t into del of t. Okay, at t equal to t. I'm stressing minus 10 by t. I can write minus 10 by t del of t at t equal to t, or you can write it as, actually del of t is a signal which exists at t equal to 0. So here you cannot write del of t because it is t units shifted. So I can write it as del of t minus capital T. Okay, del of t shifted by t units. All right. Okay, now what happens at after t and 2t? What is the slope? Slope is 0 because here it also is a straight line. You can see it's a straight line, so the slope is 0. So I can give 0 from t to 2t. Okay, and what happens at t equal to 2t? Here there is again an abrupt change which corresponds to an impulse as the slope. Okay, impulse signal. And what is the orientation of this impulse signal? It should be positive because now the abrupt change is from negative to positive, right? Negative to positive side, so it should be pointed upwards, positive impulse. And what is the strength of that signal? The strength of the signal will be plus 5 by t, right? Plus 5 by t into del of, not del of t, but del of t minus 2t, because del of t is shifted by 2t seconds, 2t units. So del of t minus 2t. Everything is over. Now what we have in d square by dt square s1 of t is 3 impulses, right? 3 impulses. And I have told you finding the Fourier transform is very simple because impulse signal is the most easiest signal to find out its Fourier transform. Why? Because what is the Fourier transform of impulse? Fourier transform of del of t. What is that? It is 1. Okay, so so that's why I'm saying it's the easiest signal to find out the Fourier transform of. Okay, so what is the Fourier transform of this signal? Okay, let's find out the Fourier transform. So d square by dt square of x of t will be having, or I can represent it as the signal is equal to g of t. I can name it some g of t, which is equal to 5 by t into del of t minus 10 by t into del of t minus capital T plus 5 by t into del of t minus 2 into capital T. Okay, therefore what is g of omega? G of omega will be, okay, what is g of omega? G of omega is 5 by t into Fourier transform of del of t, which is 1, minus 10 by t into Fourier transform of del of t minus t is, you have to use the time shifting property of Fourier transform, which is e raised to minus j omega capital T into Fourier transform of del of t, which is 1, plus 5 by t into e raised to minus j omega 2t, because the shift is here 2t into Fourier transform of del of t, that is again 1. So this is equal to, I can write it as minus 10 by t into e raised to minus j omega t plus 5 by t into here it is 5 by t into 1. I'm writing 1 as e raised to j omega t into e raised to minus j omega t. There will be no difference. Okay, plus in this term e raised to minus j omega 2t. I can write e raised to minus j omega 2t as e raised to minus j omega t into e raised to minus j omega t. Why? Because I can now take e raised to minus j omega t common from these two terms. Okay, so this is equal to minus 10 by t e raised to minus j omega t plus 5 by t into e raised to minus j omega t is common. So what is left in the bracket is e raised to j omega t plus e raised to minus j omega t, just nothing but 2 times cos omega t. Okay, and now you can see 5 into 2 is 10 by t into e raised to minus j omega t cos omega t. Here is 10 by t, so I can write a total 10 by t, I mean 10 by t into e raised to minus j omega t common from these two terms. So that will result you 10 by t raised to minus j omega t into cos omega t minus 1, right? Okay, fine. So this is g of omega in its simplified form, but what we have to find out is x of omega, right? X of omega or x1 of omega, whatever. So the relation between g of t and x of t is this thing, d square by dt square of x of t is g of t. So taking Fourier transform on both sides, so I can write some more here. So the relation is d square by dt square x of t equal to g of t. Taking Fourier transform on both sides, j omega the whole square into x of j omega equal to g of j omega. That is the differentiation property says. That means if x of t and x of j omega Fourier transform pairs, then d by dt x of t will be having a Fourier transform j omega into x of j omega. Similarly, d square by dt square of x of t will be having j omega square into x of j omega. That's what we are going to apply here. Okay, so therefore j omega the whole square into x of j omega, that is given g of j omega, right? Okay, this equation j omega square x of j omega equal to g of j omega, which is equal to 10 by t into e raised to minus j omega t into cos omega t minus 1. Therefore the final answer x of j omega, that's what we have to find out. It is equal to what is j square? It is minus 1, right? So this is I can bring minus omega square to this side, right? So minus 10 by omega t square e raised to minus j omega t into cos omega t minus 1. This is the final answer as the Fourier transform of x1 of t. Okay, we have got one more sub question here. This is a square signal. Now again, I'm advising you don't get scared on this signal, because evaluating the Fourier transform of this signal is even simpler than the previous case, because you know, a little intuition will lead you to think that a one-time differentiation of this signal will give you what? A single time differentiation of this signal will give you impulses, and if you get impulses, the Fourier transform of impulse is 1. Very simple. So the first step, as you think, is to find out d by dt of x2 of t. So let us plot d by dt of x1 of x2 of t. Okay, so I'm finding out the derivative. Okay, let's see what happens when the signal is differentiated. Okay, so beyond -4 there is no signal, so the slope also will be 0, no slope. Okay, at -4 what happens? At -4 you can see an abrupt voltage change from 0 to -a, negative. So what will be the slope? It will be an impulse signal, and it is negative. Okay, it will be an impulse signal which is negative. Why? Because the voltage changes, amplitude changes from 0 to -a, negative change, so negative impulse. And what will be the strength of that impulse? It will be -a into del of what? Del of, this is -4. So this is not del of t. Del of t should be an impulse located at the origin, but this is -4 units to the left, or 4 units to the left, so it is del of t plus 4. So minus a into del of t plus 4. Okay, and between -4 and 0 the amplitude is constant, the slope is 0. So here the slope comes to be 0. And what happens at t equal to 0? T equal to 0, again you can see an abrupt change. Now while going towards t, positive t, this abrupt changes from -a to +a. So from negative to positive means there will be a positive impulse. And what will be the strength of that impulse? The strength will be the amplitude changes from -a to a, that means 2a changes there, though. So the impulse will be 2a into del of t. You can write del of t because this impulse is located at origin itself, no issue. Okay, now beyond 0 and up to 4, the amplitude of the signal x2 of t is constant, so its slope given in d by dt of x2 of t will be 0. Slope will be 0 up to 4. And what happens at 4? At 4 you can see as t increases, there will be a negative abrupt change. Okay, abrupt change, but it is negative, so its slope will be an impulse which is oriented in the negative direction. Okay, this is impulse. And what will be the strength of that impulse? It should be again -a into del of t minus 4. Okay, -a because it is having a change from positive a to 0, so -a change, right? And this impulse is located at t equal to 4, therefore del of t minus 4. Okay, so this is d by dt of x2 of t. Okay, so what is the Fourier transform? Or I can write let g of t is d by dt of x2 of t. Okay, therefore what is g of omega? G of omega is equal to, it is very simple, because we have only impulse signals, so taking or shifted impulse signals, so applying the property of time shifting, we can write g of omega as, what is the transform of this impulse? It is -a into e raised to plus j omega 4 into 1, right? -a into e raised to plus j omega 4. Why e raised to plus j omega 4? Because it is time shifted by 4 units. So e raised to j omega 4 into the Fourier transform of del of t, which is 1. That is the Fourier transform of this impulse. Now let us look at this impulse. What is the Fourier transform? It's very simple. It is 2a into Fourier transform of del of t, which is 1. Okay, and we have one more impulse here, that is minus a into Fourier transform of del of t minus 4 is e raised to minus j omega 4 into Fourier transform of del of t is 1. Okay, so I can fairly write it as g of omega is equal to 2a minus a into, I can take minus a common, so it becomes e raised to j omega 4 plus e raised to minus j omega 4. Okay, that is equal to 2a minus a into, what is e raised to j omega 4 plus e raised to minus j omega 4? It is 2 cos omega 4 or 2 cos 4 omega. 2 cos 4 omega. Okay, I can take 2a common, so 2a into 1 minus cos 4 omega. Okay, now take it that this is g of omega. What we have to get is x2 of omega, right? So from this expression we can write g of omega will be equal to, applying the differentiation property of Fourier transform, it will become j omega into x2 of j omega. Okay, so that implies x2 of j omega, that is what we needed. x2 of j omega will be equal to 1 by j omega into g of omega, that is equal to 1 by j omega into g of omega is obtained in this equation. So 1 by j omega into 2a into 1 minus cos 4 omega. This is our final answer. So the next question is, a continuous time LTI system is described by a differential equation. Determine the output response of the system to a given input using Fourier transform. This is the thing you have to make sure of. So we have done many problems like this, so I can be a bit speeded. So what is the Laplace transform? Applying Fourier transform on both sides, it will give you this differential equation will become j omega into y of j omega plus 5 into y of j omega equal to x of j omega. Therefore y of j omega will be equal to x of j omega divided by 5 plus j omega. Okay, and what is x of j omega? You are given x of t as e raised to minus 2t of t. Therefore x of j omega you can boldly write it as 1 by 2 plus j omega. Okay, therefore y of j omega will be equal to, x of j omega is 1 by 2 plus j omega into 5 plus j omega, which is already there. Okay, now the response is to be found out. For that, inverse transform is to be applied. For that, we have to find out the partial fraction, and I can write the simplest method: 1 by big number minus small number into 1 by j omega plus small number minus 1 by j omega plus larger number. This is the simplest method you can adopt for finding out the partial fraction. That is equal to 1 by 3 into 1 by 3 into 1 by j omega plus 2 minus 1 by 3 into 1 by j omega plus 5. Luckily, both the terms are in standard Laplace transforms. Therefore, application of inverse transform is very simple. So what y of t equal to 1 by 3 into, what is the inverse transform of 1 by j omega plus 2? It is e raised to minus 2t of t minus 1 by 3 into, what's the inverse transform of 1 by j omega plus 5? It is e raised to minus 5t e of t. So that is the final answer. So happily we have done all the questions under module 3 and module 4. Okay, so stay subscribed to Pros and Experts for the upcoming modules 5 and 6 videos. Okay, so thank you.